Hey guys, I hope you can hear me. I also hope this lawn mowing that's outside right now is like not hurting too bad, because I know that it's very loud to me. Could you guys tell me how the audio is and if this is like very annoying in the background? I hope it's fine. Everything should be good. Okay, so let's get started. Hi Crystal Violet, what's up? Is this a tradition? Fine with that. Okay, let me just... Wait, you can't hear anything? That's not good. Maybe it's your volume, because it seems like OBS is at least picking up my stuff. Hang on. Let me share this to my Discord because it's always, Oh, okay, cool. Alright, thank you. Here, let me just send this off first. Usually do this. And you know, if you want to see this Discord, you can always go right into the description. But, that should work. Okay. Alright, cool. So now, the plan is just to do what I was saying. I'm going to do these, I have this mashup of problems that I created. The first 4 are sort of kind of handpicked, and the last 11 are harder and also of random difficulty. So, should be interesting to see how it works. But, wait 1 second. Let me also get my chat open somewhere else so I can be able to read it and do stuff at the same time. Because, you know, it's kind of smart to set this stuff up beforehand, but it's not a big deal. Alright, so first, I'm just going to, first I'm going to make a thumbnail, because I'm very prepared for this. Setting up the stream as the stream is going on, not suspicious at all. It's right here. And I'll just add this. You know how it goes. Because this old thumbnail is the same one as... yes, it should have a few bitmask things. And, yeah, okay, ideally don't do spoilers. That's not, ideal. 1 second. Setting up the stream as it's going on. Okay, perfect. So let's begin with just a brief idea of what dynamic programming actually is, for the people who are kind of like unfamiliar with it. And at the same time, this can serve as review. So I'm going to go over a problem that like basically everyone uses, but the reason everyone uses is because it's a really simple and nice introductory problem. So, do you need to know basic DP? I mean, it helps to know what the concept is, but you don't necessarily need to, like, be able to apply it yet, I guess. Yeah, no spoilers. Okay, so I'm gonna go with Fibonacci because everyone knows that. So the basic idea is you have this sequence. Let's call it f of n. And it has a formula for it, which is essentially, it's a piecewise function, which means that like for certain values it behaves one way, and for other values it behaves other ways. So, please teach you use to go mowing. Maybe later. I'll take custom requests after we get through this. So f of n is defined as, I think it's 0 if n equals 0. and then 1 if n equals 1. Or the other definition is f of n minus 1 plus f of n minus 2, the previous two elements. Oh, mowing missed. No, not that one, not that one. I can't do that one. Okay, now this is the problem. So if we were to write some program to like just straight up uses this definition, like for example, here's what the code would look like. Oh wait. It would just be this. And we just straight up write code that uses the definition of Fibonacci. Now think about like what happens with this code. So we begin by, let's say we call f of 5. This is also kind of a well-known diagram. Let's say we call f of 5. Right now I'm just going briefly over what dynamic programming is. Like, why are we doing this? What is this useful for? Why is it so necessary? And then after that, I'll get into the problems. So f of 5, well, it relies on f of n minus 1, which means that it relies on f of 4. So this is going to call f of 4. Actually, I'm going to do f of 3 first, but because it also relies on f of n minus 2. So it will call f of 3, and it will also call f of 4. Okay, in a similar manner, we can kind of, we can just like keep on. Oh, I didn't make these problems. I just kind of gathered them around. We can keep expanding this tree. Now, f of 1 is just like, we know it. It's like known. So this isn't going to generate any more recursive calls. But this will keep going down to f of 0 and f of 1. Now, we do the same thing here. We go to f of 4. This is going to call f of 2 and f of 3. And then we can expand all of these out tediously and annoyingly and pointlessly because that's what happens. Like, look at how big this tree is. For f of 5, we require, we want to know 6 values, but look at how much work we're doing to do this. Right? Like, there's some of this is just pointless. And actually, look at this. This whole subtree of calling f of 3, and this is the exact same thing. So like, why are we doing it again? We just did this here. Why are we doing it again here? And if we expand out to higher values, it's going to like repeat more and more and more. Why are we doing it again? So the whole point of dynamic programming is that we don't do it again. We figure out the value of f of 3 here, and we know its answer. And then when we get to this point where we require that we need to know the value of f of 3 again, well, we already know it. So we check that we already know it, and then we cut off this whole thing here. We don't redo this because we've already done it. That's what dynamic programming is. Essentially, we store answers we've already computed and use those stored answers to prevent ourselves from wasting time by redoing a bunch of things. So in terms of implementation, how would this work? Well, say you just had like a big array. Let's call it a cache, for example. Yeah, memoization is one form of DP. I'm also going to go over the other form. Like, this is called recursive DP because it's a thing. Let's say we just had a cache which was of size, like, it would store all the numbers from 0 to n. So we call f of 5. And then we do the same thing. It relies on f of 3 and f of 4. So now we do the same thing. We rely on f of 1. F of 1 we find the answer for, so now we store that in the cache. And f of 2 we don't know the answer for, so we keep going. This goes to f of 0 and f of 0 and f of 1, both of which we already know the answer for. And then once we do this, Once we do this, now we get the answer for f of 2. Alright, this is going to be introductory DP. I'm not really going over advanced concepts here. Probably not in this stream at all, because most of these problems aren't designed to be the crazy stuff. I'm not making cash. I don't even have monetization on. I'm just doing this. Right, okay. So now f of 2, we just learned. We used f of 0 and f of 1, and now we know the answer for f of 2. So let's put it in the cache. So now we've cached f of 0, we've cached f of 1, we've cached f of 2. Whatever these ants... Oh, yeah, cache. Okay, sure. I see. But we've cached these 3 values. And now we know the answer for f of 3 because it relies on these 2, and we know both of them. So now we've cached f of 3. And... comma before space. Okay, whatever. And then, so now we have to compute f of 4. Yeah, f of 1, I'm not sure. So now we call f of 2. Now, normally f of 2 would also call f of 0 and f of 1. But first, before we do this, we check that f of 2 is in the cache, and indeed it is. So instead of recomputing f of 2, we simply use that answer that we already know, and we cut it off. So f of 2 is done in one operation instead of in 3. And then we do the same thing for f of 3. f of 3 is already in the cache, so we use that answer and we cut it off. And that's it. So what it means is every value is computed exactly once. So there's no sort of like big blowing up of this tree. Everything is done once. That's the idea. And this is called memoization. Oh, and by the way, once we do this, we know the answer for f of 4, so we can also cache 4. And then we know the answer for f of 5, so we're done. This idea is called memoization, where we memoize, like memorize, but like without the R for some reason that they decided this name was. We memorize the answers that we've come up with before, and now we know them, so we don't waste time redoing it. So instead of this exponential complexity that we would have originally had, like O of 2 to the n, we compute everything once, and like everything only relies on 2 values. So it just becomes O of n in terms of complexity. So in terms of code, this is actually very simple. Cache, let's do like, let's say we're computing f of 20. Right, and then we use -1, because no Fibonacci numbers can be -1, we use -1 to represent a number that doesn't exist yet. You can also do something like this, where you just keep a Boolean array of whether you found the answer or not, and then you can use that as reference. But let's see. So we optimize it like this. If we already know this answer is not equal to -1, instead of doing the recursive formulation, just do this. Return cache event. I'll do the subscriber count when we start the actual problems. Okay, so now we know that the answer is going to be f of m minus 1 plus f of m minus 2. So why don't we cache that now, and then return that. Now this is going to be much faster, because again, it uses this idea of storing answers we already know. So this is memoization, and the other way to do it is the more popular, or the more like, it's more of what you would call dynamic programming. Yeah, everything's going to be available for rewatching. So I'll have the archive up on my YouTube. So the other form is dynamic programming, where instead of like doing it recursively, where we do a cache and store the previous answers, instead we kind of like, we sort of more mess with the idea of using previous answers. Let's compute first f of 0, then we do f of 1, then we do f of 2, and then we keep going in increasing order until we get to f of n. Right? Okay, why is this useful? Because like any value of f of n is only going to depend on previous values. For f of 3, we only need to know f of 2 and f of 1. So if we make it so we compute all of the previous values before we compute this one, then we're automatically going to know the answer to f of 3. And then when we get to computing f of 4, we already know the answers for f of 3 and f of 2. And then we just keep going. Right? So unlike memoization, which is recursive DP, this is sort of like iterative DP, where you would do it as a loop. And so you would literally just you would literally just do it. And then you store all these answers in sort of the same kind of cache, but it's an array instead. Yeah, it's bottom up. Meanwhile, memoization is sort of top down. You start at the top and then you like propagate down and compute the states like that. Right? So you just do it in this order. And then you say, in array format, f of n is equal to f of n minus 1 plus f of n minus 2. It's just an array. Right? So here's the other way you would do this. I'll delete memoization. And usually with arrays like this, you would just call them DP. Or actually, I'll call them F, I suppose. N equals 20. Then, actually, we wouldn't do the base cases in the loop. So first, we begin with the base cases. We know f of 0. Base cases are just values you immediately know. Like, for example, the base cases in these would be 0 and 1 because they don't rely on previous values. How much will the stream cover? Yeah, it'll be like a lot of problems, I suppose. Probably going to go on for a while. So we know f of 0, we know f of 1 equals 1. And then we just straight up like do this. That's all it is, because like that's it. This works because we guarantee that when we're computing this, we already know the previous answers. And in general, in this sort of like loop style DP, what you need to make sure is that yeah, matrix exponentiation. Sure, I'm definitely not going over that right now. But yeah, that is an extra thing you can look into. But the idea with this is that you just need to make sure, increase the font size, I suppose. You just need to make sure that when you compute a value, you already know the previous values. That's all the ordering has to satisfy. That when you compute a value, you need to know the values that it depends on. But other than that, you can do it however you want. Okay, now this is called pull DP, where this answer sort of pulls from previous answers. There's yet another way that you can do this, and this is actually the way I prefer, which is called push DP. And the way push DP works is you see that f of 2 relies on f of 1 and f of 0. But instead, you can sort of reverse these conditions. You can say that f of 0 contributes to f of 2. You can say that f of 1 contributes to f of 2 and contributes to f of 3. You can say that f of 2 contributes to f of 3 and contributes to f of 4, and so on. Personally, I find this easier to work out. It's based on preference, basically, but the way you would implement this is you still begin with the base cases, but now you would go here, and you would say f of I, actually, we'll ignore 0 because it's 0 anyway. So then f of I plus 1 plus equals f of I, because f of 1 contributes to the next value, and f of I plus 2 plus equals f of I, because it also contributes to the second next value. And then by the time we get to f of 2, we will have already processed all the things that contribute to it. So in the same, like by the same argument kind of, we know f of 2 by the time we get to it. So when we get to f of 2, we're allowed to push it out because we already know its answer. So this is called push DP. Hi Kostya, how are you doing? Are you tuning in for the later brickage that's going to happen? I do not have every Monday off. This is a specific Monday that I do have off. But usually, I probably will stream on like Wednesdays or something, because that's also a day when I'm open. It kind of just depends. That's the reason you should join the Discord, because it's always going to be inconsistent. Like, stuff is always happening that changes my schedule. So, yeah, in the Discord, which is in the description, like it's like right here. You can just open it right now. It's right here. You can get notifications for everything. So when things change, you can still find them. Or you can also go to the community tab on my YouTube, either way. Both of those places I'll be announcing streams. And even on this Code Forces thing, like right now, you can see this stuff. But yeah, there's probably not going to be any sort of element of consistency. I'm sorry about that. Anyway, that is my intro to DP. Took about 20 minutes, I don't know. Yeah, alright, now we get into the problems. Are y'all ready to have your minds not blown, but sown, I guess? Okay. I am recording this. YouTube will automatically upload this as an archive later. So that will be fine. Alright. You have, okay, I've already read this, but you have a given integer n. Find a number of ways to fill all 3 times n tiles with the shape described in the picture. Oh, wait, actually, first, time-old tradition that always before starting, I add my current subscriber count to my template. And I've definitely explained this before, but the ultimate goal with this is to try and get a memory limit exceeded verdict by having it take up so much memory that it crashes. I reckon it'll take about 9 million or so to do that, so maybe next week, we'll see. Alright, you have a given integer n. Find the number of ways to fill all 3 times n tiles with the shape described in the picture below. Upon filling, no empty spaces are allowed. Shapes cannot overlap. Right, okay. So, let's kind of just like think about what can we do to this. We have this grid. Let's think of it. Wait, figure out some way to draw this. Will I mod it back when it exceeds? Maybe. I actually don't know what I'll do. Hopefully by the time I get there, Code Forces will have upgraded their systems and it'll be 512 megabytes or something, so that it won't ever be a problem. Like, I'm sure with the prowess of computing power, like the standard memory limits are going to be higher or something, and then constraints will just have to be higher too, because computers are going to be stronger, I imagine. Not actually sure how much farther we can take it, but it should be pretty good at least. Okay, so we have to fill all of the tiles with the shape. This is barely visible, is it? We have to fill all of the tiles with the shape. Let's do it like this. Which means, like, no matter what we do, we have to put something in the top left corner. Right? So there are like 3 different ways to put something in the top left corner. We can do it like this. This is one way. We can do it like this. Or we can do it like this. Let's look at all of these cases. What happens with this problem? Right? So here, look at this. Like, this is a problem. Because when we put this down, what are we going to do about this cell? There's no way we can put something down to fill this cell. Wait, this is like... There's no way we can put something down to fill this cell because all of these are blocked by this. So automatically, we can't do this one. We're blocked from putting this L shape down. So we have 2 other ones that we can do. We can do this one. And then what happens here? Now again, look at this cell. There's only one way we can fill this cell, and it has to be with something like this. So if we put this one down, we automatically have 2, what is it? Like, we automatically fill in 2 of the rows. So this is one way to do it. And the other way that's possible is this one. But again, look at this cell. Like, look at the cells that are blocked off by when you do this. How does putting this down affect the state? It makes it so it's harder to put down other things. And the only way to be able to fill this cell is by doing this. So again, when we put something down, we cover the first two rows. So there are two ways to do this. We can do it like this, or we can do it like this. Blue with blue. And either way, it fills in the first two rows. So the first thing is, if we have an odd number of rows, then there's no answer. And otherwise, well, okay, so the answer you can think about it mathematically, but this is a DP stream, so I'm going to solve this with dynamic programming, even though it's like kind of unintuitive. Let f of n be the answer for a grid of n rows. Yeah, it's just 2 to the n over 2. It's fine, but I'm going to do it with dynamic programming. So let f of n, actually, wait, okay. I said that. I said 2 to the n over 2. It's okay. Let me first, okay, so all I've done is Fibonacci, right? And so it's kind of like, well, how do you apply this sort of concept to other things? So there's a sort of strategy you can do to approach a dynamic programming problem. There are a few things you need to know to be able to make it work. You need to know the state. The state is what information are you carrying, like what information are you storing answers for. For example, in Fibonacci, the state is just n. That is, we're storing the answer for a, what the hell? What just happened in chat? Okay, I'm gonna trust that that mute was warranted. So this essentially, the way this works is we store the answer for a single number, and that number is the only bit of information we need. However, we could have other states, like we could have states that rely on two numbers. For example, in a grid, one possible state could be the row and the column of a cell. And so it's not able to just... I didn't see the messages, by the way. All I saw was that they were removed, so I'm not exactly sure what happened. But this is the way this works is it's going to be two numbers. And really we can have a state be whatever we want. It can be like 12 numbers if we want. We could have I've solved the problem before that was 6-dimensional dynamic programming. Like it relies on 6 different numbers. And this is like stupid, but it's possible. The state is the information that we need to maintain. And with the state, you should be able to uniquely determine the answer. So I'll kind of get into what that means later and what kind of states aren't enough information. Because the state has to represent the whole problem. So there's also another thing. We need to know the transitions. For example, in Fibonacci, the transition would be f of n is equal to f of n minus 1 plus f of n minus 2. In certain problems, this is the first problem on the mashup. I'm doing the mashup in order. So you can also find the mashup in the description right now. Yeah, no, I'm reading chat for questions mostly. I just saw that something weird happened and I was confused. F of n is equal to f of n minus 1 plus f of n minus 2. So this defines a way to find the answer for a given value based only on previous values. This is a recurrence. And perks for spamming Kalen Gallon IGM chat ors will mean ban. I think that's the best I think that's the best reward for doing that. Yeah, I can put the current problem on Sure. Although you have to have access to the mashup, so just click that link. F of n is equal to f of n minus 1 plus f of n minus 2. So the way this works is this just defines a way to find the answer for this based on only the previous values. And this is what dynamic programming needs, because all we know are these previous values that we've computed. Right. So there's one or two more things depending on how you argue. You also need, for example, base cases usually. For example, we are given that f of 0 equals 0 and f of 1 equals 1. In most cases, this is the only way to make this happen. Like, we need base cases because otherwise, like, there's no end to the things we're computing. If we didn't have these, this definition of f of n would go into negative numbers, and it would go down to negative infinity because we never stop. We just keep relying on previous values, but these previous values, like, don't exist. Yeah, they do need base cases. Someone figure out if Mikey should get mod. I don't know yet. So this is only in context of Fibonacci. So anything I forgot? I guess we'll figure out later. But this is the basic overview. If you can find all this information, you can do a program with dynamic programming. If there's no like plausible state that stores enough information to find the answer, it probably isn't dynamic programming. It just depends. But you definitely, like, obviously you can't apply dynamic programming to everything. How can you understand if a problem is DP or not? That is a hard question. It's not really understanding if it's DP. It asks, like, the way to determine if you can use DP is just to check if you can use DP. Like, in terms of competitive programming, you're allowed to try a lot of different solutions and see what will let you do the answer. Yeah, part of it is experience. Part of it is other things. Yeah, overlapping subproblems is also another way to think about it. But the idea is just think about DP and then try and come up with this information and see if you can apply it. And if you can't think of any plausible way to apply a dynamic programming solution to it, then it's probably not DP and you can think of something else. It's not really necessary to try and like flag a problem as DP and then and only then think about it. You can just think about every problem and try to solve it like a dynamic programming problem. And if it works, then it works. And if it doesn't, then you can try other strategies. DP makes sense until they like... Yeah, harder DP comes with kind of experience. You need to like... There are a lot of tricks you can do with DP, and oftentimes you just need to come across them in problems to be able to understand them. It's way too many like things to go over. But anyway, I'm going to explicitly go over this process for this problem. The idea is, for every 2 rows, there are exactly 2 ways to tile it. For every 2 rows, there are 2 ways to tile it. So let f of n be the answer for n rows. First of all, there is one way to tile no rows. You simply don't put anything in. So the base case, I'm going to use... Actually, no. So the base case, and yes, I am drawing with a mouse, by the way, which is why the handwriting isn't perfect. The base case is f of 0 is equal to 1. Because 0 rows, we have exactly one way to do it. We just do nothing. Okay, the base case is this. And then now we need... Well, okay, so this is the state, right? The only thing that matters is the number of rows we have. We don't care about the column because we're filling in entire rows at once. So the column is irrelevant. All we care about is the rows. So the state is f of n. The base case is f of 0 equals 1. And then what happens here? Say we have 4 rows left. Well, in one like move, we have... Yeah, that's a really good quote. Those who don't remember the past are condemned to repeat it. In one move, we can fill in 2 rows, and we have 2 different ways to do it. So think about what this would be in terms of f of n. The transition is we can fill in the row one way, and then we add f of n minus 2, because we fill in the row like this, and now we're interested in the number of answers for 2 rows, because now we don't care about these rows. We've reduced the problem to having 2 fewer rows. So if we fill in one way, then we add f of n minus 2 to the answer. We can also fill it in the other way, which I will label as brown. We can fill it in like this, which is also plausible. And then we fill it in the other way. And then we add another f of n minus 2. And the way you work this out is, you basically think about, when you have a problem where you're solving for n rows, what can you do? Like, what does the problem ask you to do? In this case, the problem asks you to fill in the tiles. So just think about the ways you can fill in the tiles. That's essentially the way this works. You have 2 different ways to fill in tiles. Both of them remove 2 rows from the equation, so you work with a problem with 2 fewer rows. And both of them ask for the answer of having 2 fewer rows, which is f of n minus 2. So we get the recurrence f of n is equal to, one way we can do it is to add f of n minus 2, and the other way also adds f of n minus 2. So the recurrence finally is f of n equals 2 times f of n minus 2. Oh, wait, that's ugly. Where did I learn dp? I think that's a good question, actually. I think it was Yusuko training. That was my foundation for everything. Although it took me a long time to understand. Like, if you're having trouble learning DP, that's natural. It took me months to get. But at the same time, I think one of the problems was that I didn't have enough examples. So, alright, okay. So, like, I mean, this is clearly optimizable, but the whole point is that we're doing this with dynamic programming. And this is it. This is the recurrence we have. Let me move this over. Alright, we have our 3 things. So let's do it. But actually, here, wait. Let's apply the age-old trick of converting this into iterative DP. Yes, this is for beginners. Let's apply the age-old trick of converting this to iterative DP, where we essentially replace the parentheses with brackets. And now we're working with arrays instead of this. This is magic, isn't it? But now, like, we just straight up have a recurrence where we can do arrays with this. So as long as by the time we compute f of n, we know f of n minus 2, then we can find the answer for f of n. Which means it's equivalent to saying, when we compute f of n, we want to know all previous values. We want to do f of n after we do f of 0 to n minus 1. Which means let's just compute f of increasing order. So let's do it like this. Yeah, okay. That's true. With f of 1, when you have exactly 1 row, there's no way to do it, because you can't put any tiles down that make it work. So yeah, you're right. Sorry, there are 2 base cases. F of 0 equals 1, and at the same time, f of 1 is equal to 0, because there's no way to do it if you have 1. So let's do this now. How this work? C into n, f n plus 1. We need to know the numbers from 0 to n. F of 0 is equal to 1. F of 1 is equal to 0. For I is 2, I up to n. F of I is just 2 times f of I minus 2. And then we're done. Oftentimes, once we compute this recurrence and we make all this work, it's just nice. See if it works. Hopefully it does. We get 4. Alright, we've solved the first problem. I'm going to ideally not go as slow for all of these because it's going to take a long time, but that's the idea. So yeah, procedurally, find the state, find the information you need to know, find the base cases, and find the recurrence. And oftentimes, it's a better idea to find the recurrence first, because then the base cases are just like, you need enough base cases so that you don't like recur infinitely, which means at some point you have to stop. So it helps to first know the recurrence so that you know the values that you need to stop. And in fact, even during this stream, after I figured out the recurrence, someone pointed out that I had the base case wrong and that I needed more information. So it's generally a good idea to first find the state, and then find the recurrence that operates on the state, and then find the base case that works with it. Yeah, also base cases are kind of like the easiest part, because it's just like thinking about certain values, and you can easily compute certain values. I'll take specific requests after this mashup. Okay, right? So this is it. This is all the code is. We just straight up do it. F of 0 equals 1 because with 0 rows, we have exactly one way to fill in the rows validly. Like we just straight up do nothing. And f of 1 is 0 because with one row, there's no way to do anything. There's no way to fill in these things. F of 2 equals 2. Yeah, that also works. In terms of a more intuitive base case, you can define it like this, and then f of 1 equals 0, and not worry about f of 0. Like, f of 0 kind of represents the way to do it with 0 rows, but at the same time, it's also just convenient implementation to define it as 1. Like, it's kind of the same. Actually, no, I'm not going to talk about math, but like, you can do whatever you want as long as in your implementation you get it right. You can mess with things. It's okay to do that, as long as it's correct. Okay. How can you come to the state? Well, that's a good question. It's kind of, at the same time, computing, like, what is the problem asking? This problem is asking, given a grid with n rows, or given a 3 times n grid, specifically with n columns, my bad, what are the ways to tile it? So this 3 is fixed. The 3 really doesn't matter for the answer. So the only like input value is that we have n rows. So to solve a problem on n rows, what can we do? Well, we can try and reduce the number of rows, and we can make it so we have the exact same problem, only with fewer rows. With other things at the same time, you could just, either they don't affect the answer or they do. And if they affect the answer, then you need to store them in the state. So, as an example, yes, the input defines the state, kind of. This wasn't 40 minutes per problem. I spent like 20 minutes explaining the first thing. So, if we had, for example, more than 3 rows, like this 3 wasn't fixed, we had, for example, k rows and n columns, then we might need to define the state differently. We might need to define it as f of n and k, because now the number of columns is important. It just depends on what the answer depends on. And it's going to be hard to figure out the state. That's like the hardest part. I think with intuition and sort of relying on practice problems, or like the problems you practice, yeah, f of k n maybe, either way. Like with sort of practice problems and previous problems and stuff like that, you can get better at identifying what you need to store. It's mostly intuition. Okay, and fun fact, there's a much simpler formula you can do than dynamic programming, because people wanted that. It's simply 2 to the n over 2. Because for every 2 rows, you have 2 ways to do it. and the rows are independent of each other. So it's just 2 times 2 times 2 and over 2 times. Right, but there's no reason to implement that. So that's another way to do it. I'm just doing it specifically with dynamic programming. Okay, anyway, that was the first problem. Let's do the next one. Does not say I solved it. I did solve it, right? Okay. Alright, now we get into more serious problems, I suppose. You have a string consisting of n lowercase Latin letters. You decide to type all substrings of the string s. Okay. A substring of s is a non-empty string x equals s of a to b, so like a contiguous group of characters. Yeah, but the keyboard is broken, and therefore you can only use k different letters. In the IGM video, I said don't stop, keep trying things. Now I say I have to stop. When did I say that? Keyboard is broken, namely you can use k Latin letters out of 26. So you're interested in the number of substrings that you can still type using the broken keyboard. Okay, n is 26. N is 2e5, k is 26. Yeah, the mouse is loud. I don't have a better way of drawing. I'm eventually getting a writing tablet. Eventually, just not yet. Oh, coach mode? Okay, that makes sense. I'll just stay in coach mode then. It's not really that big a deal. Oh, that's what you meant. Okay, yeah, sure. Well, that's not you stopping. That's the program stopping. That's different. Okay. So let's formally write this out. Abacaba. Is that how this works? Yeah. Do I have a PC too? No, it's just the Wonder laptop. Facecam coming at 10,000 subscribers. You guys could get me there, you know. It could happen. It's all up to you guys. Now, the first step for doing this is, like, the first step of attacking this problem is, like, what can we even type? We can type any character that's valid. That is, we have it on our keyboard. But, like, at the same time, all these valid characters are kind of the same. It doesn't matter. Yeah, I have my water bottle with me. It doesn't matter what the character is. What really matters is if we can type it or not. So let's reformulate the problem now. We have a bunch of characters. And let's define a character to be 1 if we can type it using the keyboard, and 0 if we can't. So for this problem where we have A, B, C, Abacaba, and we have A and B as the possible ones, then all of these characters are going to be 1s and the rest are going to be 0s. And now, asking for the number of substrings that we can always type is equivalent to asking the number of substrings where everything is a 1. Now, there are many ways to do this. You can do this with math. I would prefer not to. Let's solve it a different way. In these sorts of counting problems, there's like this universal trick that you should always try. You should try to fix something. That is, say, what I'm going to do here is I came up with this kind of by intuition, but the way to fix something is say, I'm going to solve for this being the last character. This C is going to be I would use math for this, but it's a DP stream, so I kind of have to. So I'm going to say that we're going to solve it for the number of substrings that end at this character. So the substring that ends at this character, the substrings that end at this character. And like, how do you come up with this? Well, you just kind of got to try a lot of different things. And one of the things you can possibly try to fix is a single end of the character. So if I can compute the answer for all substrings that end at this character, like the number of substrings we can type that end here, then we can sum all of those up and everything will be perfect. There are many other things you can fix. For example, you can fix the, another thing to try is possibly the length of the substring. You can say we're going to solve for all substrings of length 2. I will take suggestions later, not right now. We're going to say we're going to solve for all substrings of length 2, and then maybe that'll work out. Who knows? It doesn't work out here. And one of the nice things to fix is the end of the string. So let's do that. Now let f of I... Actually, wait. Before I even do that. Now, when we're solving for a specific end of the string, what really matters? Well, what matters is just the position. We only care about where we are. Because we don't care about the beginning, all we care about is the ending point, and the ending point is a single point. Oh yeah, current problem link. This is, please remind me to do this. I am absolutely going to forget. By the way, this other link is for Mbit. It's our program. It's our competition. You might want to check it out. It's like, it's got stuff like, we've had DP problems in the past. So if you want to do more DP, you should check that. Okay, I can't do this, but it's prepared by myself and others, so hopefully it'll be some level of quality. If you like contests, you should check it out. Okay. Let's get back to it. I'm not... Can I pin stuff in chat? Do I have the option to do this? I don't think I can. Oh, we've definitely had DP in the past. At least 2019, maybe not 2020. I do have to plug in Mbit, yes. It's kind of like contractual obligation. Wait, how do I pin a message? I'll figure that out later, maybe. What do I have to do? Not sure how to... Oh, wait, like a comment? Or... Oh, do you mean like a comment on the video? Or like a live stream chat? Live stream chat, like, I'm not sure how to do that. This is all I see right now. I see put user in timeout, hide user, add mod, report, and remove. What do I have to do here? Like, I know I can do it for comments. I've done that before, but it's not here. Or is it? Not sure what you mean. Like these 3 dots? Who is content indeed? I'm not sure myself. Try to pin any random comment. I'm not sure how to do this. Why is it that when I'm struggling to do live stream stuff, I have more viewers than actual problems? Or like after I type it, I have this. And all it says for me is remove. No, working with the live stream isn't DP, it's MP hard. Do I have plans to set a contest on CF? I actually have, kind of. I made this like testing round and it kind of just got ignored because it was a single blog and then like not many people checked it out, but I do have a round that I wrote. Most of the problems are kind of lame, but it exists if you want to see it. You can find it in the gym. Okay, I'll Google how to pin a comment on live stream. I can remove all other comments. Sure. Okay, I have this open on my phone right now. We're figuring this out, I suppose. Yeah, I have more viewers than I... What? This is like Dream getting like 80,000 viewers for a blank screen. How do I pin a comment on my live chat? Oh wait, it needs 100K to do that? Okay. Look, it's saying online that like you need a certain number of subscribers to do it. I don't know if it's possible, like for me, because I'm not that big in the YouTube world yet, but maybe later, I don't know. Like I just don't have the option. Try popping out chat. Does this work? Do I have anything better here? I am not in college. Okay. I don't know how to do this. I'm just gonna get back to the problem. That is a good plan. Yeah, I'm in high school right now. I did try pinning my own comments. Like, if I do this, it just says remove, and then that's all I have. I can't do anything with it. Okay, I kind of like have to re-explain this now since we got so off track. So you're given a string, you're given a certain set of characters you can type. You want to find out how many substrings exist where you can type all of the characters. So we define a... So we define a problem. Don't we have enough mods already? I think it's fine right now. Like, there's not much to moderate. Click on manage moderators, then remove niche chat. Yeah, I've been wanting to do that for a while, actually. Okay, so we define this to be a 1. We define it to be... Yeah, we define this to be a 1 if and only if we can type it. Can we use bit masking after converting to 0 and 1? Well, I wouldn't say that. It's kind of like... I don't think that's possible, no. I'm 17 right now. So what I was saying was, let's fix the right endpoint of the string. So, let's say f of I is equal to the number of strings, or the number of substrings f of I. I wanted to pin comments so I could have this exist as, like, I could have the current problem pinned, and so it wouldn't be as weird to see. But let's define f of I to be the number of substrings that end at I. That is to say, no, that's just what it is. The number of substrings that consist of only ones that end at I. What should I make you mod for? I need job and becoming mod is big on resume. Well, I'm sorry, but you're not being hired today then. So, let's say we're solving for this character. And so the first, you can find the problem here if you want to read it. Mod you or you get the donut. You're getting the... I thought you were taking the donut anyway. So, we're here. Yeah, the chat is very distracting. I agree. So we're here. So if this character is a 1, then if this character is a 1, then actually let's say it like this. If this character is a 0, then like no matter what, I is a 0. So there's no way we can have a string ending at I that has only 1s, because like we already don't have a 1 automatically. I is not 1. So instead, now we assume f of, so automatically, if let's define this as array A, then if AI equals 0, f of I is equal to 0. Before we continue, can we extend this to a subsequence that it's not necessarily contiguous? Well, if it's not contiguous, then it would just be the number of characters validly, and we can either have them or we don't. So it'd be like 2 to the number of 1s, like minus 1 possibly. That would be the answer. It wouldn't be necessary to do DP here. But so AI equals 0 implies that f of I equals 0. Otherwise, we assume that AI equals 1 because it's the only other possibility. Then what happens? Well, first, we have the string consisting of only AI. So automatically, we have at least 1. But then also, like, what about the other substrings? Well, all the other substrings that are going to be attached to this one have to end at the previous character. Now that's cool, isn't it? Because like now we're just interested in what ends at the previous character. And well, we're interested in the number of strings that have only 1 that end at the previous character so that we can extend them by 1 and include this character. But like by definition, that's f of I minus 1. It's the number of substrings of only 1s that end at the previous character. So the recurrence would be f of I is equal to the number of substrings we can extend, plus this character itself, because that wouldn't be included previously, so plus 1. And then the answer is over all possible ending points, how many substrings do we have? Which is essentially saying it's the sum over all f of I. And the base case is simply for a string of length 0. For a string of length 0, we have no ways to do it. We have no substrings because there are no strings at all. So then we can define it like this. Actually, I'm going to write this in red or something. Bitmasks? Yes, I do have a plan for that. Actually, I think the next problem is bitmask. I kind of like handpicked that one. Right? State, recurrence, base case, we're done. That's it. So let's do it. We have n and k. And then we have the string. And then we're going to just define a. Okay, well, it's a very like weird kind of bitmask DP. DP on trees? I don't think we do. Maybe I can do that after the stream possibly. I'll try and find stuff like that. But let's just store, instead of like storing the number of typable characters, we can instead store an array for each character and check if that character is typable or not. That's true. An array is a degenerate case of a tree, I guess. And then we say automatically it defaults to 0. So then and then we read in a character, and now it's on the keyboard, so we define it as typable. And this subtracting A just means that we normalize it to the numbers 0, 25, instead of that's what this does. So now what we can do is we can reformulate it. We can create this array A that's 1 if a character is typable and 0 if not. If typable si minus a, ai is equal to 1, else ai is equal to 0. And of course you can get rid of the if condition, do like ternary stuff, doesn't matter. I don't have school today specifically. I normally do have school on Mondays. Because this was like the end of the marking period or something. Right, now let's define the function. This is the dp function. And the base case is that f of 0 is 0, which we define. Then we use this. So if ai is equal to 0, then our occurrence says that f of I is equal to 0, except we one index this, so therefore we need to add to I plus 1, not specifically I. And otherwise, f of I plus 1 is equal to, as the recurrence states, f of I plus 1. Then the answer is the sum, so let's do that too. And that'll be it. I'm really glad you can't clip this on YouTube. I'm really glad you can't make clips on YouTube, because I'm sure there would be so many of me struggling to pin a comment. It would be sad. You know, part of the nice thing about YouTube is that because I've fleshed the solution out so much, it has a really high chance of like just being right on the first go. So sometimes it's an idea to like think out a solution really hard before just blindly going at it. You can use DP instead of recursion always. Not necessarily. It depends on, like, the idea of DP is remembering previous answers. So if you have like 10 to the 18th previous answers, like for example, it depends on an array element or something, then that may not necessarily be possible. Well, it's not necessarily a session, because this whole live stream is going to be available on my YouTube channel after it's done. So even if you miss part of it, it'll still be here. Also, I intend to go through these later problems quicker. We just got very distracted here. But the idea of DP is remembering previous states. So if there's nothing to remember, for example, if every state you visit is different, there's no reason to use DP. Like, it's not going to help. That's just where it applies. Okay. Move on to the next one. Yeah, this is where the bit masks comes in. Bit mask comes in. Current problem is updated. Just gonna highlight that. Okay. Berlin's shop sells N kinds of juices. Each juice has its price. Each juice includes some set of vitamins. There are 3 types of vitamins: vitamin A, vitamin B, and vitamin C. Each juice can contain 1, 2, or all 3 types. Future 1v1 lockout with second thread. That is a possibility. Kind of depends on things. I do see that as a possibility. It could happen in the future. Yeah, collaborations are possible too. There are also a lot of other channels that are starting up that are doing tutorials. For example, this one guy, Algorithms Conquered, is one that I've looked at before. So you can check him out. There are also other ones. But yeah, I'm sure collaborations are possible in the future. We'll just have to set things up. Is knapsack DP? Yes, it is a form of DP. Is FFT DP? I don't know FFT, but probably not. I don't think it is. so each juice can contain 1, 2, or all 3 types. We need to get juices so that we can have all 3 vitamins. Is greedy DP? Generally not. Sometimes, generally not. So what is the minimum total price so that you can get all 3 vitamins? Alright, now this one is kind of messier, because the state isn't so simple now. Let's say we have some function f of x. Wait, let me scroll up. Let's say we have some function f of x. Actually, I'm just going to say this is problem C. Let's say we have some function f of x, where x is the state that we're trying to find the answer for. Is dp dp. Yeah. No, it's not. But like, what is x? Well, what we want to know is what's the cost for obtaining all 3 vitamins, right? And these vitamins have no relation to each other. So the way it works is, like, what can we do here? In some sort of state, we need to have it so we have information on. Contest is restricted? Yeah. To open this problem, first you have to click the first link so that you can be invited, and then you can open the specific problem. I'll put that there. So we need to store if we have the vitamins or not. This difficulty is 1200. So in a state, we need to know, do we have the A vitamin? Do we have the B vitamin? And do we have the C vitamin? And specifically, we can store it like this. This is a 0 if we don't have it, or a 1 if we do. This is a 0 if we don't have it, or a 1 if we do. This is a 0 if we don't have it, and a 1 if we do. So there are 2 ways we can represent this. We can do it like this. We can make it 3 variables. And we say that this represents if we have an A or not, this represents if we have a B or not, this represents if we have a C or not. And that's like one way to do it. But there are other ways to do it too. Instead of doing that, we can compress all of these 3 into a single number. Because notice, this is either 0 and 1. This is also either, I'm doing problem C. This is also either 0 or 1, and this is also either 0 or 1. This is binary. Isn't that cool? We're interested in the binary state of whether we have an A or not, whether we have a B or not, and whether we have a C or not. But like, just think about computers. Like, computers do things in binary. We use numbers in binary. So why don't we make this whole thing just a single binary number? Let's have 3 digits. The first digit is A, the second digit is B, the third digit is C. This first digit represents do we have an A or not. This second digit represents do we have a B or not, and this third digit represents do we have a C or not. So A has the value of 2 to the squared, which is 4. B has the value of 2 to the 1th, which is 2, and C has the value of 2 to the 0th, which is 1. We're doing problem C. I'm gonna like do this now. I'm gonna write the thing at the top. And we compress this binary sequence into a single number that represents all of them at once. This is called a bit mask. It's a mask of bits compressed into a single number that represents the state we want. And this is more generally known as bit mask DP. We have a state f of mask that basically says, what is the minimum cost to have it so we've satisfied everything that the mask says we have? So for example, if the mask is 1, 0, 1, which is equal to 5, then we have to have satisfied that we have an A and we have a C. Why is it called rolling? I don't think you can super chat. I don't have... I'm not a partner yet. Actually, I haven't even applied yet. I probably should do that at some point. But I don't have any sort of setup for that. So f of mask represents lowest cost to satisfy the mask. We can also introduce another state. This is sort of an implementation thing, however you want. N mask, which is defined to be the lowest cost. Lowest cost to satisfy the mask, where you've only used the first n strings. This is generally how DP would be done. Because you're going through the strings in order, you can actually abstract out this part and just kind of get rid of it. It'll be implicit, but this is the explicit definition of how to do this. It's the lowest cost to satisfy the mask using the first n string. Oh, where did these numbers come from? This is just how binary works. The first thing takes the position of 1. The second thing takes the position of 2. The third thing takes the position of 4, etc. Like, it's just a binary number. That's all we're doing here. We're converting these zeros and ones into a single binary number. And it's convenient because computers work in binary. Yeah, it's also representing kind of a set of objects, and then the bitwise operations do some cool things. But let's go with this. So f of n mask is the lowest cost using the first n strings. All right, how do we do this sort of recurrence? This is where I prefer to use push DP. So I'm going to kind of describe how to use push DP right now. Yeah, 3-variable truth table, sure. So what does f of I mask contribute to? So the transition for f of I mask would be considering the I plus 1th string. And what we can do is we can represent these strings also as a bit mask. We represent the string as a separate bit mask, which asks, do we have an A in this string? Do we have a B in this string? And do we have a C in this string? And we do it the same way. This is 2 to the 2, this is 2 to the 1, this is 2 to the 0. And then we'll call this mask M or something. So we have a mask for the state, and we have a separate mask for the string. And somehow we have to combine them. So the transition is, either we don't take string I plus 1, in which case we just still have f of I plus 1 mask, because we've considered the first I plus 1 strings, and we just don't use it this time, so that's fine. Or we do use it, in which case we have to consider what happens. So this is f of I plus 1, because we now consider the I plus 1 strings. But what happens here? Well, this is where the truth table comes in. So this is... You can sort of bash out the way to do this transition like this. We can say we had before we might have had it before, in which case we don't care about whether we have it here. Or we do have it here, in which case we don't care about whether we had it before. Right? So there are 4 cases. Either we had it in both of them, we had it before but not here, we had it here but not before, or we have it in neither. And well, this is just asking, like, if we have it in at least one of them, we have it no matter what. So this is bitwise OR. You're going to bitwise OR the masks together. Because if you have the bit in at least one of them, then you're going to have it afterwards. So it's mask, logical OR, M. And the cost for this is the cost of taking string I plus 1. So you would have to consider f of I mask plus the cost for that one. The base case is simply we have 0 strings, and obviously we can't have anything satisfied, so it's 0. Because we don't have any cost either. So now let's do that. This binary number is just the number between 0 and 7, so we can represent it in an array of size 8. First we need number n, and then we can make this array of size n plus 1 and 8. Then we can do this by checking. So we want to make it so if we can't get to a state, then we want to make it so we're never incentivized to use that state. One way to do this is just to initialize everything to infinity, because that's the highest possible cost we can have, and therefore we'll never want to use it. So let's define infinity to be some huge number, like 10 to the 17th, which we'll never get to in the cost because the costs are just 10 to the 5th. Then f of I and j is simply infinity. This also gives us a convenient way to check if we can't have it at all, because if we never reach the state, if we never reach any state, then we're totally fine. So we also define the answer to be infinity, and then we say cost string s so now yeah, if you watch it later and leave a comment, I'll try to answer it. Int string mask equals 0. So for int this is the position in the mask, I'm going to stick with this notation of representing a C as the first digit, B as the second, A as the third. So this has the power of 2 to the 0, power of 2 to the 1, power of 2 to the 2. So the corresponding character is this minus the position. So in the first position, this will be a C, second will be a B, third will be an A. Then we just go through the string and see if we have it. Then if we have it, string mask plus equals 1 left shifted by pause, which is the same as saying 2 to the position. Okay. Is it possible to do live subtitles? I could try that. I'm not sure if that's possible. Wait, what is this? If your video doesn't require closed captions. It should be automatic. If it doesn't, I guess it'll have them after. Wait, are you able to enable them? I guess you can't. That's kind of annoying. Yeah, I guess it's not possible live. Sorry about that. We'll have to figure that out later. I'm not sure how to do that. Yeah, okay. Let me finish this off. So for a certain value of I, we just like iterate through all the possible values of masks, which is 0 to 7, and then we find what it pushes to. So the first case is that we take nothing, and therefore we just do this. So fi plus 1 mask, it's just the same thing, equals min f of I plus 1 mask f of I mask. That's the first case. And the second case is we do the same thing, but we do take it. So f of I plus 1 mask bitwise ORed with string mask equals min plus 1 mask bitwise OR string mask plus the cost of taking this string, which is cost. And then the answer is any possible way to the answer is the minimum cost having considered all of the strings of having the full mask of A, B, and C. So the answer is, redefine it here, f of n and 7, because 7 is the number that represents having all of the bits enabled. If the answer is infinity, then we never reached it, and therefore we want to print -1. And that's how this works. This is bitmask dp, in a sense. What? What did I do? No matching. Oh. F of I mask, yeah. And it breaks, nice. Cool. Oh, because I never, right. We want the base case, setting this to 0, as we define here. $15. This should be -1, we have no answer. Should be 13. Should be 250. It should be 16. Okay, by the way, in the time that I have for the stream, I don't expect to get through all of these. That's not the point. The point is that, like, the point is that we just, I don't know, I'm trying to be elaborate here and trying to explain everything, and yeah, the point is not speed, that's what I'm saying. Kind of lost my train of thought multiple times, but we do get the problem. Okay, yeah, there is no reason to spam a question 6 times. I will try and read all of the chat, and if I don't, you don't have to, like, keep saying it. But, practice div 2s probably, I'm not sure. That's kind of the way to go. But yeah, don't spam, that's just annoying. The timeout will only last 5 minutes, so we'll be able to talk more later. So this is just D. I don't even have to change the link every time, it's just problem D. Yeah, let me read the rest of the chat, I may have missed things. From where can I practice number theory? I think you can, that should be a tag. Go to problem set and then, add tag, and then number theory. And here you go. You can also pick difficulties if you want, like 2400 to 3500, which I'm not going to do, but you can do whatever you want. Coforces is pretty nice. These are all 1200s. The way this distribution works is the first is 1000, the next three are 1200, and then the rest are randomly distributed between 1400 and 2000. So some of these are possibly quite hard. Okay, your friend Mishka and you attend a calculus lecture. I'm scared of saying names. Lecture, there's so many ways to mispronounce something. Lecture lasts n minutes. He tells AI theorems during the ith minute. It's really interesting in calculus, but it's hard to stay awake. You're given an array T of Mishka's behavior. Mishka is asleep during the ith minute of the lecture, then Ti will be equal to 0, otherwise it will be equal to 1. Mishka is awake, he writes down all the theorems he's being told, otherwise he writes nothing. You can keep him awake for k minutes straight, but you can only use it once. You can start using it at any valid minute that would work, sure. Your task is to calculate the maximum number of theorems he'll be able to write down if you use your technique only once. So wake him up. Watch your competitive programming journey video. I mean, you could take the same route. It's not necessarily necessary. There are a lot of ways to get good, but I'm not sure. I think just a general good rule of thumb is practice whatever you want to be good at. So if you want to be 12,000 rating on Codeforces, you can do a lot of Codeforces problems, because that will tell you exactly what you have to be able to do to get 12,000 rating on Codeforces. Okay, why is this DP? That's a good question. Well, you can think of it like this. Practice juggling later. I'm doing that today. I said it. I'm doing it today. I'm doing it today. I hope. I hope. All right. Okay. So here's the idea. Let's think about this problem like this. 1, 3, 5, 2, 5, 4. Now this is DP like a certain sense of the word. It's not well, actually no, it is DP for sure. So this is 1, 1, 0, 1, 0, 0. And the way this works is you want to pick a range, and then automatically you're going to get all the numbers in this range. But at the same time, you're also going to get all the numbers in this range where you have a 1, but not the numbers where you have a 0. Right. So let's do it like this. Let's say we pick an arbitrary range. Then what we're interested in is 3 things. The sum without modifying the numbers of this, the sum without modifying the numbers of this, and the sum of all of the numbers in this. Okay, now there's a cool way to do this and a not cool way to do this. I'm probably finding the not cool. So here's the idea. The idea does indeed exist. Right. So what we're interested in is the normal sum of this. So let's break this into 3 parts, right? We want the unaffected sum of this prefix of the array. We want the unaffected sum of this suffix of the array. And we want the total sum of this. So in terms of dynamic programming, it's still building off of previous answers. Let P of I be the unaffected sum of the prefix. Okay. So any prefix will consist of 2 parts. You can think of it like this. It's the last element and everything else. So this red part is the range corresponding to P of I. And this orange part conveniently corresponds to P of I minus 1, since it's everything but the element you just took, which is the same as the previous prefix. So P of I is equal to A of I, whatever A of I may be. This could be 0 if the value is 0, or something greater than 0 otherwise, plus P of I minus 1. This is in some sense dynamic programming. And we can do the exact same thing for the suffix. S of I is the unaffected sum of the suffix. Actually, let's say it's the suffix of the last I characters, because that's kind of convenient. Actually, is it? No, it's not. Let's say it's the unaffected sum of the suffix from I to N. And then we're just kind of interested in that. And then the formula is basically the same. We draw the same diagram. This is the part we include. This is everything else. So this is S of I, and this is S of I plus 1. So S of I is equal to A of I plus S of I plus 1. Okay, now that's these two parts. What about the middle part? Isn't that fun? Well, the idea is, this is a thing. Why are you spamming dots? Is this Morse code? I can't read Morse code. Is someone fluent enough in Morse code to understand this, or is it just nothing? If it's just nothing, then that's annoying. But yeah, I guess you can mute. I don't see the point of that. Mashup will be active? Yeah. Everything, like this whole stream, everything is going to be available afterwards. So you can find the problem. First, click this link, and then you can click this specifically. Everything will be in the description. But yeah, everything, the mashup, the video, all of it's going to be afterwards. It's like it's going to be available afterwards. Okay. Now this is a cool thing called prefix sums. We're interested in the sum of, not the unaffected sum, but the sum of all of the array elements. So let's do it like this. We let prefix of I be the sum of the first I elements. Not the unaffected sum, but the sum of the first I elements specifically. Then it's the same recurrence as P of I. I'll do it in green. Prefix, sound like my math teacher. Prefix of I is equal to AI plus prefix of I minus 1. And the way this works is, what we want to do is we want to use this to get the sum of anything. Get the sum of any range. So let's consider some range we have in the array. But we want to represent it as sort of this prefix thing. So let's consider the whole prefix that ends at the end of this range. Okay, but like, look, man, we got this like gap here, right? What we're interested in is this. And we have, all we know is this. So what if we just like, we do this, but we take out this gap. And then we're just left with the thing we care about, right? So this gap on this range L and R, this gap is the prefix of L minus 1 elements. And then this gap is the prefix of R. So to get the sum on LR, we just take the whole thing and then subtract out the stuff we don't want. So it's prefix of r minus the prefix, I'm capitalizing L so it doesn't also look like a 1, minus the prefix of L minus 1. And that's how you would get the sum on a specific range. This is more commonly known as prefix sums, but it's like, it's a form of DP, so it still counts, I would suppose. I think that's why it was tagged that. So now let's do this. Let's just like, this is going to be tedious, and there are smoother ways to do this, but I'm doing this explicitly because it's like, just nice. So then, we use AI to represent the first array, BI to represent the second array. And we can think about it like this. So I'll just define it explicitly. So the base case here would be that, well, there is no p of -1, so you have to define p of 0 explicitly. And p of 0 is just a of 0. So we can think of it like that. P of 0 is equal to a of 0 times b of 0. This is convenient because if it's a 0, we don't want to count it. And if it's a 1, we do want to count it. So if we just multiply, it's going to work out. Then we can do the recurrence. P of I is equal to a of I times b of I plus p of I minus 1. Do the same thing for suffix. I'm going in order, yeah. But the general idea here is that once we're here, the way this will work is cadence algorithm. I'm not sure how that would apply. It's like a fixed range subarray. We can do the same thing, except for computing prefix sums, I usually have a specific trick where I, instead of doing the array explicitly, I store a variable that represents this, and then it's not a recurrence anymore. It's sort of like you just maintain this variable that represents the suffix as you go along. I'm not going for 8 hours now. R plus equals AI times BI, and then you can do it like this. And that makes it so you don't have some sort of edge case or anything. And then we can do the prefix sums. Isn't this font size enough? I can't zoom in that much farther. Like, it just kind of gets awkward. Is it the quality? You can also improve the quality of the video. I think. Okay, but the way this would work would be, I want to find the best. So let's fix the start point of the interval we're using. I plus k minus 1 is less than n, because that's the end of the interval. And then now we say we're going to do this. On this whole array, we take this interval. This is I. The end of this is I plus k minus 1. Which means that this interval is the suffix I plus k. And this interval is the suffix I minus 1, or the prefix of I minus 1. So current equals 0. If I is greater than 0, cur plus equals the p-value of I minus 1. If I plus k is less than n, we do the same thing. I plus k. And the way to do this is just simply this. We consider the prefix of r. If necessary, we subtract out the previous one. And now we consider it as the answer. What ASMR? All I'm doing is typing. I guess that works though. Does this exist? It does indeed. Yeah. So we just like compute these three things and then combine them. I said this wouldn't be smooth, and it's not. But it's a way to like force it to be dynamic programming. That's kind of what I'm trying to do here. Okay, we're on to E. It looks like this has fewer solves than normal. So that sounds fun. Let's do this. There are n people and k keys in a straight line. Every person wants to get to the office, which is located on the line as well. To do that, he needs to reach some point with a key, take the key, and then go to the office. What is the shortest time I've finished this code contest? That is a good question. Yeah, you can also do prefix sums on 0, that's true. Officially, I think it was like 40 minutes or something in some div 3. Don't exactly remember. So then you need some reach point with a key, take the key, and then go to the office. In order to determine the minimum people needed for n keys. Okay. So let's think about this. You have a bunch of people. Ideally, I will try and go a bit faster through these. You have a bunch of people. Each person is located on some point. Let's think of it like this. And you have a bunch of keys. Keys are going to be also somewhere. Yeah, William Lin is pretty fast, I would agree. And the way this is going to work is every person is going to take a key. Oh, and there's also some office somewhere, I suppose, is how this works. And every person is going to take a path that first goes to a key and then goes from that key to the office. Oh yeah, that div 4, it took me 37 minutes. I guess that would be it. Although I didn't, never mind. Read a problem and don't get an idea. Try to get more ideas. Like, if you don't get an idea instantly, that's normal. Generally, hard problems take a while to even think of anything. But then, as you think more and more about it, stuff will become more clear. For example, you can find some observations or things. It is a possibility. Yeah, he's very fast, I would agree. I took a while on Kickstart G because I, am bad. Well, problem C was, a pain. Okay, so the basic idea for this problem is, and I only came up with this so quickly because I've seen it before, but, the trick here is you don't want any crossed paths. So consider some, I'm going to move this down. Consider something like this. Well, first of all, you're going to assign every person to a key. So we can think of it like this, where we just kind of draw out this assignment. Right? And then this person will go over here, for example. What to do if you're stuck at Noob and code forces? Well, that depends. How effective is your practicing? If it's not working, you probably want to try something else, I suppose. You would want to see what's working, what isn't, and I'm not sure. Improving is just kind of like a random thing. You just gotta like throw yourself at problems and be better at thinking. And the only way to do that is to have the experience. I don't think it has a greedy solution. There's no guarantee that the greeting would. Oh, come on, you've been newbie for like 3 weeks. There's no way that the greedy solution would be guaranteed to work. Wait, I'm gonna draw this here. So now let's consider this. These paths are crossed. So like, the idea is that we don't want to cross these. Because consider this. Consider it like this. Let me figure out some way to illustrate this that isn't true. If you have a greedy solution, it is possible with greedy, but I don't think it works. That's the thing. So you have an assignment like this. But like, I claim that this green assignment is always going to be better. That if you have two paths where this is less than this and this is less than this, but this is assigned to something later than this, then it's not optimal. And this is just like well known. I mean, the way to prove this could be something like this, where it could possibly you could possibly do out the casework. Like, you can do out this sort of casework and realize that in every possible case, the green assignment is going to be better. But this is just true. Like, this is an idea that is always going to 7 streams for a single contest. What the? Yeah, basically this green thing is going to be better. Let me try and figure out some way, like, non-annoying way to prove this. Because they're, like, if you do all the cases where, like, for example, the blue points can be between the reds, or they can be on one side or the other side, there are a lot of cases that you can all work out, and they're all going to say the same thing, that this green path, this green assignment, where if you don't cross the paths, is going to be better. But that's the idea, which basically means that the assignments of the keys you do are going to be in increasing order. So you have the numbers 1, 2, 3, and 4, and you have 5 possible slots. Then it's going to be something like this. Like, for example, this would be the assignment. But you can't cross them, so you wouldn't have something like this. Every, like, assignment number will be less than the next one. Why am I saying this so elaborately? Because what it means is you can automatically assume when you've assigned the third person that you've already assigned everything before that third person. And we're trying to do DP here, right? We're trying to get some sort of reasonable state that represents everything we need to know for the problem. And I've just shown that the only thing we need to know for the problem is the last person we assigned. So that's cool, right? And also the position at where we, like the position we're at and the last person we assigned. So if we were to write some DP based off this, it would be DP of position and last person. That would be it. That's the only information we need to know. Because with this information, we can uniquely determine like the answer and the problem we're solving and everything. But you see how this wouldn't work if we can do them in any order, because it's not enough to just say that we put down 3 last, because now, like, what if we put down a 1 or 2 afterwards? It doesn't say anything. All we know is that we put down 3. But in this problem specifically, putting down 3 implies that we put everything down. And it also implies that the next person we're going to put down is going to be 4. So just off this information, we know everything. And that's why DP works here. Yeah, again, I'm not exactly sure how to prove this sort of lemma-like thing, but that's how it would work. And also notice that the cost for going to the office doesn't like change when you do this, because either way you still use the same set of keys. So DP at position last is the minimum cost to have it so you're at position. Yeah, you could use bitmask too if the ordering wasn't so fixed. That would be an example of bitmask DP, I guess. But yeah, you would have 2 to the n state, and that's just not going to work. How would you do this? So this is the minimum cost to be at this position and have used the you've used this many people already. Then the answer is the maximum over all is the maximum. Let me see. The way to recover the answer is just the maximum over all j of, or maximum over all I suppose, of dp of I and the number of people you have, which is n. Because that's just the way it is. Like, it doesn't matter the final position. All that matters is that you've used all n people. Okay, how do we compute this? Well, let's see. To push dp or to not push dp? That would be the question. Suppose oh yeah, right. Whoops. Sorry, the minimum. You're right. Whoops. It's okay. I would have gotten through the sample and realized that didn't make sense eventually. But yeah, it should be the minimum. Whoops. So the reason I find push DP so intuitive is because it uses the problem statement. With push DP, the transition is either you assign a person to here, in which case you get a new state based on that assignment, or you don't. That's why I think push DP is so nice, because you don't have to like reverse the transitions to figure out how things work generally. Push DP is where you you explicitly use this state and like kind of push its value out to future states, like pause +1, last +1. Oh my god, that handwriting. Yeah. Jesus. But like that's the idea. You use the state to push out that value to future states. I think that's the easiest way to do this. So dp pause last, you have 2 transitions. Either you take this one, or you don't. If you do, you end up with position +1, and now you use the new person. Or this is problem E on my mashup, which you can find in the description. Or you don't take it, in which case you have pause +1, but the last value is still the same. The base case here would be that it would be dp of 0 and 0. That's true. Indexing is very nice with push dp. I agree. dp of 0 and 0 will be defined as 0. And everything else will be equal to infinity. Because like we don't want to accidentally, for example, say that we're at position 0 but we've used one person. Because that could lead to an answer that is like not good. So we want to initialize everything to infinity to make sure we don't accidentally like see states that don't exist or something. But this is the idea. We're going to assign things in increasing order so we can do DP. It's kind of like, it's a bit like the DP from like, what would it be? Like the, actually no, it's not, never mind. It like resembles longest common subsequence, but it isn't. Okay, let's read in the values. LLP, so I'll read that in. And then we do that. And then we read in the first K values. And we want to sort them because otherwise the ordering we do wouldn't make sense. We want to make it so they're sorted in increasing order or non-decreasing. Then we define DP as follows. We have n plus, we have k plus 1 possible positions to be in, because 0 is kind of like a non-existent position, and same for this. This is like non-existent amount of people. And we have n plus 1 possibilities for the number of people. We can be within the range of 0 to n. So then we do this stuff. dpij equals infinity. That works, right? 110 to the 17th is big enough, yeah. So now let's go through. I equals 0, I is less than or equal to k. I didn't even work out transitions yet. Nice. Oh yeah, we did. So either we take this and then we get the cost of adding this person, or we don't take it and then we have nothing. So first, we don't take the person. Then it's just DP. I would welcome you, but I don't know how to pronounce your name still, so I can't. I plus 1 j is equal to min dp I plus 1 j dp I j. If this is infinity itself, then we just kind of ignore it because it's like the minimum of infinity and infinity. And then we do take person. This is only possible if we're not on the last person already. So if j is less than n, then dp I plus 1 j plus 1 equals min dp I plus 1 j plus 1 dp I difference between dp and k and kn. Well, it's just kind of like, it's just the array size. What really matters is how you define it. And I define it to be, we're at this position and we've used this many people. And so we have 0 to n, like the possibilities for people are 0 to n, the possibilities for positions are 0 to k, so that's just kind of how it works. Push DP is what I'm doing right now. It's essentially the idea that instead of having DP recurrences rely on previous states, you instead use previous states to like push them out to future states, which is what I'm doing kind of. So this would be rely on dpij plus the cost, which is, no, not really. I mean, it's kind of the same. Like, you can just study whatever works for you and it's almost universally going to be fine. Like, there's a very, very small amount of problems where like a certain kind is necessary. In general, both push and pull DP will both work. So this is dp I plus 1 j plus 1, dp ij plus the cost would be, let's see, it would be the cost between it would be AJ, the jth person, minus BJ. This is the distance between them. And then it's the distance between that key location and the position of the position of the yeah, push DP is more of a style choice than a concept. Like, it's not different. It's still DP. DP series next. I can cover, maybe I can cover the ActCoder, like the ActCoder DP thing in like a different video or something. Yeah, we can also define it to be like DP. We can also define it to be DP. I'm gonna do this in a different color. Like, for example, DP of IJ is like the minimum of DP of I minus 1, J minus 1 plus cost, and then DP of I minus 1, J. This is a possibility too. I just prefer to do push DP like this. I mean, I prefer to do push DP because I feel it easier. Yeah, I'm not sure where the timestamp is. It's like near the very beginning, like before the 20-minute mark, I think. So this is the same idea. We have to add the cost here. So this is the cost of taking the person. And then, well, actually, for this, we don't even need the minimum because no matter what, like, what we really care about is DP of K and N. Because any answer we would have already had before will continue to have it later on. So K is fine, and we need to have N people no matter what, so that's like what we need to do. CO DP K, and the fact that this is infinity doesn't matter because no matter what, we'll reach this anyway. So now we get 50, I hope. Or we don't. Did I do max instead of min? Nope, I did not do the base case. Once again, I made this mistake before and now I made it again. Where we explicitly define DP of 0 and 0 to be 0. Oh wait, someone asked in my blog or a different blog? So we get 100. What? Did I do the cost wrong? 20 should go to 40. 100 should go to 80. Oh, it's the... Oh, okay. It's not the sum of times. It's the maximum used time. Oh, I misread that. Okay. In that case, it doesn't change much. Then instead of this being plus cost, it's the you consider it as the maximum of DP I J and the cost. I don't get why it's 100 either though. Is this still wrong? It feels still wrong. Wait, how did we get 100? Yeah, okay, something's still up with this. And the idea is that, what? 11 to 15 to 10, 11 to 17, what am I doing? Definitely missing something. Oh, wait, whoops, this should be I. My bad. Yeah, we're taking the ith person. And this error doesn't actually make sense, but I do sort them both. Oh, that's another mistake. Sort this up to the actual value, not the previous one. I'm sure there'll be more such mistakes in the future. Heh, 69 viewers, nice. My Cofor's handle is Galen_Colin. You can find that. It's just my name, but like last underscore first. Let's see. We read the values in. We sort this by n. We sort this by k. Do the infinity and put everything to infinity. Make this 0. Iterate that to not k. Iterate this to n. Don't take the person, or we do take the person, and then the cost is the maximum of this and the time it takes for this person, because it's just how the problem defines it. It's the maximum maximum time anyone takes. And then the answer is dpkn. Yeah, okay. Looks right. Submit first, think later. Nice. Okay. So we do have wrong answer on test 5. That's interesting. In that case, what have I done? Is 1e17 big enough? Should be. Oh no, this should be this, I think. Is that? Yeah, okay. Because the I is the position. My bad, my bad. More indexing errors. Yeah. It's more of a typo than anything else. I just kind of like didn't think. Like, you know, you have those like brain typos where you just totally gloss over something stupid. Okay. Alright, so that was E. Before we move on to F, I'm going to grab some more water, because the more hydrated you are, the better of a thinker you are. So what I'm going to do is I'm going to paste on a picture of a water bottle here so that you all may boost your own ratings. And yeah, I'll be right back. I return. I did leave myself a note to unmute the mic. Okay, let me read chat, make sure I didn't miss anything important. Well, it wasn't a stick. It wasn't a stick, actually. What I did was I cropped this part, but I cropped it badly, so it was like this black part. Let's see. If DP is mysterious and confusing, look down how to do top-down DP because it's just brute force with memoization. Yes, I do agree with that. That is a very good way to think about DP, especially for beginners, because it's straight up just you remember the answers you already know. That's the whole idea of it. It's a great way to think about it, especially if it's a new concept to you. It's interesting how my viewership goes up when I'm not doing anything, and then it goes down when I do things. This is like a very weird dynamic of streaming. You guys can hear me, right? Have I been talking at nothing for the past couple of minutes? I hope not. Sanity check. Can you guys hear me? Let me check myself. Okay. A permutation P of size n is an array. I should just ghost the string. Yes, I am 17. That is correct. Permutation P of size n is an array such that every integer from 1 to n occurs exactly once in this array. Let's call it permutation an almost identity permutation. If there are at least... Wait. Oh, okay. Almost identity permutation if there exists at least n minus k indices such that pi is equal to I. Your task is to count the number of almost identity permutations for given numbers n and k. N is up to 1,000, k is up to 4, which is interesting. Oh, this is problem F. I should update that. So the way this works is like... whoa, Demoralizer in the chat. How are you doing? Yeah, I do kind of have a deep voice. That is fair. So the way this statement works is, like, consider some array of length n, for example, n equals 7. And you got some stuff like, just consider the positions. A permutation is like any array so that every number from 1 to n occurs exactly once. So it's like 2, 5, 4, 3, 1, 6, 7 would work as a permutation. But if I replace this 7 with a 2, it wouldn't work because then 2 would occur more than once and 7 would not occur once. So everything has to be the same thing. Okay. That's what a permutation is. And an identity permutation is defined to be a permutation where every number is equal to its index. So they say an almost identity permutation is an identity permutation, but 3 or 4 of these elements but up to k of these elements can be out of order. Is this annoying casework? I don't like that. Wouldn't like if it's annoying casework. Yeah, an almost identity permutation is, for example, this element can be something else, such as 6, which would force this element to be something else, because now you can't have the 6 be there. I personally am from the US, by the way. Sure, a lot of you are from India. That's what my analytics says. Like the vast majority of my viewers are from India. Which is why I'm streaming at this time. which is sort of inconvenient for people in the US, but it works for most time zones. Right? So if we have an almost identity permutation, the way this works is like, if we displace some element, then that means that this can't be a 6 anymore, which means it has to be something else. So either it's a 4 or it isn't. And let's see. Why does it have to be 4? That's not fun. Yeah, it would be casework. It would be some stuff like cycles. I have not been to IOI, no. I actually haven't even made I haven't made camp yet. I can try. I'm trying this year. Yeah, these problems are random. So either this is like a 4 or you continue it. But basically the way a permutation works is that it can be decomposed into cycles. Or for example, say you swap these two elements. Then if you follow this element, like say you start here, and if you follow this element, you're going to end up here. And if you take some sequence of like going here, you'll eventually be able to come back to this element. And that's where you get a cycle. Most of these cycles are going to be here, where you just like go here and then back to it. Wait, who are you talking about? I definitely don't practice 6 hours a day. You mean Demoralizer? He's pretty good. Very good. If a kid with age 18 goes to college, can he participate in ICPC? I don't really know the rules for that. I haven't looked because I myself will be 18 when I do go to college. I don't like this problem. If n was 3, then there would be only one cycle. But the issue with n being or k being 4 means you can have 2 separate cycles. And that's slightly annoying. So I don't actually know what's up with that. All right, what does this mean? Okay, most of the elements are equivalent. Yeah, I know. There's like, why is this tag DP? That's my question. Why is this tag DP? Because I don't see a solution with DP. Well, actually, arbitrary k would just be like selecting some number of integers greater than 1 that's summed to k, and that would be annoying, but it would be possible, I suppose. I don't see how to do this with DP. Does anyone in the audience actually know a DP solution? Because there's a way to do it with math, and that's fine, but... Oh, is it like number of derangements? How'd this work? Derangement is a permutation that has no fixed points. Oh, I guess, okay, and choose k would be DP, that's true. Okay, they count factorial as DP? Fine. Oh, no, okay. The 6-hour thing, that's definitely not current. I practice like way less now. In fact, most of my practicing is just the videos I make. But okay, I also said that 6 hours was an upper bound. It was not 6 hours every day. 6 hours was like maybe weekends where I didn't have much homework and I had a lot of time on my hands. And I just spent all of it thinking about problems, but that was not the norm. Maybe I did not make that clear when I said it. Yeah, 6 hours a day would be insane. You'd reach red in like less than around a year, something like that, if you tried that hard. No, I wasn't in the IOI team at all. I'm gonna eat something because my jaw is starting to hurt from talking so much. So, well, in terms of DP, I actually don't know how to do it. But there is a mathematical solution. Yeah, I was not in the IOI team at all. I'm not sure if I have good chances of making it this year. Because despite my rating being high, in terms of like Yusuko, like the competitors, like Yusuko is not. No, it's like I'm exercising my jaw because it's talking. I don't know. Maybe it doesn't help. I did say practicing 6 hours. Did I? No, I'm pretty sure I would be an upper bound. Okay, yeah. So at least n minus k indices that are in order means that there are at most k indices out of order. So there are 4 cases for k. Let's fix k. We're interested in less than or equal to k, but let's just fix a number x. Let's just fix a number x so that, like in x positions, this is not equal to this. What gave me the motivation to start a YouTube channel? It was kind of just on a whim. Like, someone asked me to... Oh god, are people from Blair here? Oh god. If so, why? It was kind of just on a whim. Like, I'm pretty sure someone, I think Nietzsche, asked me to, like, do a screencast of, like, some Div 3, like, around 661, and then other people from Blair, I hope not, around 661, and, like, I just did, and then I realized that I liked it, and then I just kept doing it. That was basically it. There wasn't, like, some elaborate thing or anything. Yeah, what's up, Peter? I think a graduate, but still. What is my secret? That's a good question. I don't know. Like, I honestly wouldn't be able to tell you. It's just how you practice and whether you do it right. I did not have a strong math background, no. I did practice a lot. At least in the past, I did practice a lot. Yeah, I do have math phobia, which is why I don't like this problem. But okay. So we say we have specifically x out of order, this exact number. So let's say x equals 1. And then, so like, let's say, for example, let's say this 3 is not equal to 3. So let's say it's equal to 7 or something. But then the problem is, if we have this 7 here, then this has to not be a 7. But we can't make it not 7, because if we did, then we would have two elements that aren't the same. So for x equals 1, there's nothing we can do. The answer is 0. For x equals 2, we can do something like this. Say this is no longer a 3, then it's a 7, and then this would become a 3. And if it were anything else, then we would again have the problem where we have too many elements to change. So therefore, this has to be a 3. Which means, how many more school years do you have? This is my last one, so I only have one more shot for IOI. So x equals 2 would mean that you're interested in the number of ways to pick two positions to put them out of order. Which is to say, you have this number and choose 2. X equals 3, then you have 3 positions, but all of them have to be together. Here's why. Because, think about this, we'll do the same thing. And then what do I make this? If I make this a 3, then we have 5 positions now, but we only have one number that we can make wrong anymore. So if we do something like this, where we make this a 5, we can't do this because we've already used all the 3 numbers. No, there's like a explanation for being stuck in orange. I will look after I solve this problem. I'll talk about why orange seems more like a trap than it actually is. So basically the idea is if we make this anything other, if we make this equal to this, then we end up in the same situation as x equals 1. So this can't be a 3, it has to be something different, which means this will be something like 5. And then if we make this something else, then we have too many things, so this has to be a 3, and therefore we have a cycle of length 3. So we're interested in the number of ways to pick 3 elements to do some stuff. Okay, IQ or intelligence? That is a question. I think it does, honestly, because CP is pattern recognition. If you're inherently better at recognizing patterns, then you'll just be better at CP. Like that is kind of fact. So there is some sort of relevance to like there is some sort of relevance to how good you are at like pattern recognition and stuff. But it's not necessary. It'll mean you'll get better faster, but it's not necessary to get good. Because with enough experience, if you just like know everything, you'll just know everything and then you'll be able to do everything. So the more knowledge you have, you'll just be better. And even though IQ plays some sort of a role, it's not like a limiting factor. It's not like if your IQ is X, then your maximum possible rating is Y or something. It's not like that. Every rule ors. Yeah, I agree. Anyway, for x equals 3, you have three possibilities. X equals 4, the final one. By the way, demoralizer, I could ask you the same question. What motivated you to inspire, or what inspired you to start your channel? Are you trying to demoralize people all around the world? Okay. So over here, basically, there are two possibilities. Either you can have this cycle be of length 4. For example, like this can point to 5, this can point to 6, this can point to 7, this can point to 3. In which case, we have n choose 4 ways. That's not a shot, I'm just playing with your name. I do think your channel is really good. Because there aren't many like language specialized channels from what I know. Maybe there's AppCoder and stuff, but other than that, I don't know. And then otherwise we could have 2 cycles. So for example, we have a cycle like this, and then we have n choose ways to do that, n choose 2 ways to do that, but now we have n minus 2 elements, and we want to pick another cycle of 2 elements, so it's just n minus 2 choose 2. So the possibilities here are n choose 2 times n minus 2 choose 2. Okay. This is basically the answer. We just like sum up all of these, right? So how do we compute n choose k? We use the formula n choose k is equal to n factorial over n k factorial times n minus k factorial. What is happening? One year is a long time. You could learn a lot in 1 year. For example, maybe I'll know FFT in a year. Probably not, but I might. Who knows? Anyway, we define this function factorial n to be defined as n times factorial of n minus 1. And this would be how you could do n choose k, but like don't do that because like just don't. Because this is like too big. You're gonna overflow if you compute factorials. And I guess you could actually think modulo. Look, I think the way it works is because n choose k is always an integer, if you compute it modulo something, then even though you did it the modulo, it will still be an integer. And therefore if you use a modulo, it's gonna work out. But there's like just a better way to do this. Like n choose k is equal to n times m minus 1 times m minus 2 times m minus 3. Or m minus k. Dot. And this is over 1 times 2 times 3 times dot times k. And that's like the formula you can use, because then it won't overflow. Okay. So, oh yeah, I guess true. Because the numbers are big enough for that to be a problem. Alright, but what does this have to do with dp? I guess this is... I guess this is just the thing. I think this is the formula for like number of derangements or something. So you can use some sort of DP approach to derive these formulas instead of like thinking about them, I guess. And this would be the derangements recurrence or something. I don't know. Is that how that works? I guess it would be, but that's basically the idea. So let's implement this first. N choose k is defined to be this numerator. C into N to K. If K is less greater than or equal to 2, yeah, the binomial coefficients you can do with dp. And it's plus equals nck and 2. It should be plus. That took way too long. Jesus. Actually, most of it was answering questions, so I guess it was fine. And we get 0. Oh, wait. 1 because the identity permutation itself is a permutation. Fun. Okay. Y. What is... What? 4 times 3. Should be greater than? I guess it would be greater than. Yeah, okay. $21. Oh, come on. Oh, it's not even that, because you can also pick the elements in whatever order you want. Oh my god. I don't want to rewrite this formula, but basically the way to fix this is just to, like, get rid of this part. Like, it's just this. I'm pretty sure. Or not. Or not. Okay, wait, what? I'm very confused now. Have I done this wrong somehow? Yeah, but I'm overcounting somehow, is the thing. Like, I'm already overcounting. So I don't exactly know what's causing that. Yeah, I guess that's true. It's not exactly equal to that. Guys, this is why I have math phobia. This is justification for not liking math. Wait, okay. I'm gonna re-explain this after because I'm kind of confused myself. I think this whole thing is wrong. That is indeed a possibility. Okay, so this can go both ways. So it actually needs to be 2 times this. And then this formula is even more complicated. No. Yeah, I see what you mean. How would you even do derangements? There's some DP for derangements, right? Derangements of 4 elements are 15. Okay, I'm gonna trust that. What? Wait, what? Let me just look this up. Yeah, I'm still struggling. That's more accurate. Oh, you can use pi? Okay. Oh my god. There are 9 derangements? Okay. I'm gonna trust you guys. I want to go back to like the standard things that are chill and just like normal DP and not bashing out math. What difficulty is this? Oh wait. Okay, does it work? Alright, fine. So here, let me explain how the hell this happened. Yeah, Wikipedia has a table. Alright. So say you have a permutation. I guess there's a less complicated way to say this. Say you want one element to be out of order. Like, you can't do that, because like one element just can't be out of order. But say you want 2 elements to be out of order. Then you can do something like this, where it's equivalent to the number of ways to pick 2 elements, and then the number of ways for them to be out of order. Yeah, sure, I'll try and derive it. So the first thing is n choose 2, but then you need to know the number of ways for it to be out of order. It's not wrong answer. So n choose 2 times the question mark. And for x equals 3 and 4, it's the same thing, I guess. You would want to pick 3 elements and 4 elements, but how would you do that? Because now you need to find the number of ways to make 3 or 4 elements out of order. So let's say you do something like this. You have a permutation of 1, 2, 3, and 4, for example. Let's define some function d of n that represents the number of permutations where every element is not equal to its index. You can do this in many ways, I suppose. You can do it with, for example, like inclusion-exclusion principle, where you say that like all 4 elements are out of order, and like, or at least 4 out of order, at least 3, at least 2. I don't know. But here's the idea, I guess. For this element, for this element, it has to be something not equal to itself. Let's say, for example, it's 2. And there are 3 possibilities for that. How would this work now? So I guess this could be a cycle. Oh, this is painful. So this could either be 1, and then this would close off the cycle. And there's one way to do that. And then you would have d of n minus 2. Or it could be not 1. And then you'd have 2 ways to do that. For example, it would be 3. And then you would have more things. Is the recurrence O of n? I guess this would... That place being not 1 means you can consider 1 as 2. That place... Okay, well, this is well researched anyway. But that place being not 1 means you can consider 1 as 2. And use derangements of n minus 1 for the rest of the array. What? Consider 1 as 2. Confused. Are we getting into generating functions? Okay. Alright, whatever. I don't want to do this anymore. There's some way to figure out the number of derangements. It's like some formula. Something like this? Okay, sure. How does this work? n-1 makes sense. You put that element down. Okay, well anyway, I kind of just hard-coded the formula anyway. But the idea for this is that there's some way to count the number of derangements, and that is exactly what you want. And it's based on DP or something like recursion. Yeah, I know. You have n-1 choice for the first formula, and then you like do some stuff. And then once you do this, it's like then this would be the answer here would be d of 3 and d of 4, because it's the number of ways to have 4 elements be out of order and the number of ways to pick those elements. Yeah, if it goes into 1, it's d of n-2, otherwise... Oh, I get it. Yeah, okay. Sure. That's like too smart for me. I understand, but I don't want to explain it because it's not that relevant. Actually, whatever. I guess I can. Here's the idea that Gabe et al. Are saying. To count the number of derangements, that is the number of permutations where every element is not equal to its own index. First of all, you have to put this like the element you put here has to be different from the original one. So this would be, for example, you have n-1 ways to put down the first element. And then wherever that element is, either this is the same as this one, which is like, for example, this. And then in that case, then you have just n-2 elements remaining. So you have d of n-2. So one possibility is d of n-2 times n-1. And the other possibility is you have it goes to somewhere else. Because this has to explicitly not be 1. Which means in the context of this, you can kind of replace this with 1 because this has to not be itself, and then you're looking for the derangements of that. That's what people are saying, I suppose. So then in a similar manner, you have d of n-1 times n-1, and then you sum those together and it works out. Okay. Yeah, you people are too smart for me. Let's be done with this and do more chill things. Okay, we are on to G. The onboard computer on Polycop's car measures that the car speed at the beginning of some section equals v1 meters per second, and at the end it is v2 meters per second. We know that this section of the route took exactly t seconds to pass, assuming that at each of the seconds the speed is constant, and between seconds the speed can change by at most d meters. Weird Facebook notifications. Per second absolute value, find the maximum possible length of the path section in meters. Interesting. Okay. So this kind of screams DP. And the idea would be that here's the statement in short. Essentially, you have some starting speed, for example 5, and then you have some ending speed, for example 6. And you have like a lot of moments in time where things just happen. This is way too many. You know, a lot of moments in time where things kind of happen. There's a lot of research that goes into derangements, I suppose. Yeah, anyway, I'm not going to bother with that anymore. No, my math teacher does that. It's kind of funny. He just like wildly varies his voice at times. So that's just what I did too. So in 1 second, the speed, there's some value d, and in 1 second the speed can go like in any range from 5 plus d to 5 minus d. And that's the idea. So now what do we do essentially? We want to figure out the maximum possible sum of numbers, essentially. I think. Did we count the last one? Yeah, I guess we would. It's the maximum possible sum of numbers. So, let's do something like this. Say we're at some value, we're approaching this like a DP problem, remember. So what we want to do is we want to figure out some state that fully represents the problem. So say we're here, which means we've already solved for the prefix of the first I times. So the DP state has to include the position, which should be I. But at the same time, what else would happen? Well, it would be the case that the time, like the speed that you can have here, is solely dependent on the previous speed. Because the speed you can have here like all that matters is is there enough time to brute force this? They give it 1 second. No, it's not brute force. I mean, it's like stuff. So the speed this would be solely dependent on this. So in reality, we just care about the position and whatever the previous element is. Because when we're figuring out what matters for this state, we don't care about this. All we care about is this one. So let's store the position and the previous value. And that's enough, because with that, we can fully and uniquely determine what we have to do in this current state. Do you enjoy it when I suffer on problems? Because that was the case last time. I do tend to do that a lot. So a dp of I and the previous element would be, like, what's happening here? My train of thought is like, it's not only off the rails, it's like flying at this point, so I don't even know what I'm doing. Right. So basically what happens to dpi previous? Let's do the push dp again, because I like doing that. I do love when I don't struggle, but it seems that other people love it when I do struggle, so there's some fun in that. dpi and prev can be pushed to any value where any new value, my OBS disconnected. Is the stream still, wait. Is the stream still going? What just happened? Are we good? Or are we not good? Okay, cool. Wait, let me check if it ended on code forces. That could have been a glitch. Okay, I guess that's cool. Wait, let me check if it... And my voice is loud. Yeah, it said my OBS crashed, and then it said it came back up, so I don't know what happened there. Wait, the quality's down? Seriously? What? What does that even mean? It still says... Wait, okay, what the hell? What just happened? Wait, maybe it might have reset your quality. Try like clicking the 3 dots and setting it to this specifically. That might be what's necessary. I'm gonna set it to lower for my own because I don't want to lag it too much. Is it fine now? Okay, cool. Yeah, refresh if you have to. It may just like be glitched or something. Yeah, that was annoying. It just said my OBS disconnected and then like for no reason at all, and then it came back later. So hopefully it's still good. I've done streams this long before. My computer hasn't had a problem with it. I don't know. But anyway, like obviously we can get to any value between these two. And then the value we get is just this value. So that's essentially the way this works. And we want to find the maximum possible sum. So the base case here would literally just be like the first element with the first value. That's all we can do. And, okay, how do we do this? First of all, because we want to maximize the sum, there's no point in going below 0, since both ending times are above 1, or at least 1. So we can assume that all values are greater than or equal to 0. Actually, greater than or equal to 1, but I'll just do 0 because convenience. And at the same time, t is 100, and d is less than or equal to 10, which means that like the maximum speed we would want to do would be like around 1,000 or so. Okay, stream's probably going to go on for a while. You can like leave if you want, because the archive is going to be up anyway. I guess it won't be the same fun as the stream itself, but and the content itself will be up later. And I'll also put timestamps and stuff. Right now we're on problem G. I'll put timestamps and stuff so everything will be visible quite easily. Let's see. So this is 10. Right? So like this value is at most 100. And this value is at most 1,000. And this transition affects at most like 21 things. It might be longer than 30 minutes, I don't know. Some decent amount of time. Probably get through at least one more problem. I'm definitely not finishing the mashup. Maybe I'll continue it later in like a separate stream or something. That could be a possibility. No, they are not. They are not sorted by difficulty. A to D, well, A to D are the easiest, but then E to O are completely random. So, for example, that's why K has 13 solves. Okay, I'll finish on H. Facecam at 10,000 subs. That's the deal. It's not on, right? Better not be on. Look, guys, the deal is simple. We need 5,600 more. It better not be on. I have my own stream open. If I would be very concerned if I missed that somehow. See, I actually have 51 viewers right now because one of them is me on my phone, so I can read chat. No, face reveal is 10,000. I don't know what. Where did 8K? Where did 8,000 come from? I'm doing a special video at 5,000 though. It's gonna be one of those like clickbait things, like the journey video. It's gonna be great. Anyway, for now, let's do this. So we can assume this value is at most 1,000, and in fact, it's at it's around like at most 600, because you can spend 50 turns going up, but then you have to spend 50 turns going back down, since the ending value is also around 100. But let's just assume 1,000, and then we'll do something like this. So start and hello, what is it? N, K, I'll call it D. Then we'll do DP, N, 1,000. Yeah, I did have 4.2K yesterday. Streams do wonder for this. Streams do wonders for this channel, because like I had 180 viewers at some point, and they were all watching me fail to pin a comment on live stream. Like, look at this. What was that? The Code Forces stuff does wonders for viewership. Like, these numbers are crazy. Okay. So, we'll define infinity again. No, should be negative. Because we want to minimize. And the base case is dp at 0 and start equals 0. And then the answer will be dp of n minus 1 and like the ending value plus the value itself. Okay, so what do I think of Ava's comments? I feel like some of them are unnecessarily mean. Don't get me wrong, they are funny, some of them, but at the same time, like, I don't know why anyone would just want to be mean like that. It's kind of like it's like what is it, like a mixed bag or something. Some of them are great, some of them aren't. I don't know. So dpi plus 1 j plus k equals max dpi plus 1 j plus k. Dpi j plus the value itself, which would be j. And this would be negative infinity if we can't reach it. dpn, and I think that works. does not work. I did do the base case. Wait, what? Yeah, and j plus k is less than 1,000. That's not the difference. Well, the state transition, like following the rules of the problem, it's kind of simple. Like you can make this number, you can make the next number be anything you want, provided that it's within d of the previous one. So that's how you just derive the transitions. Use what the problem like tells you to. Do whatever like operation the problem has you have, or whatever you need to do for the next element or something. Just go by the problem, and then any transition that works will be defined by the problem. And of course, like you want to add j, except like this is totally wrong. I don't know why, and I'm confused now. What is happening? N D. Should be M minus 2 or something? Wait. I mean, it should be that. This doesn't make sense. Okay, some sort of index bug. That was quick. You know, I still have the chat open. Please don't be annoying, because I can still do things. Please make a video on geometric algorithms. You know, when I proposed the topic stream idea, like this thing I'm doing right now, geometry was actually the thing I had in mind. But like, the reason I'm doing DP is because, where is this? Like, we just go here. I made this poll, and then I asked everyone what they wanted to happen inside this thing. And just like, look at this. Like, 800 votes, and 66% of them were DP. There's no way I couldn't do this. It helps to have mods for stuff like what exactly just happened right now. That like things just like people spam or something and it's kind of just weird. And it's nice for me to not have to look at chat all the time to just see what's happening. Tricky and crazy DP optimization, stuff like divide and conquer. Alien's trick maybe? I'll have to study for that, but I could. Maybe some sort of like advanced DP section or something. That's a possibility. Why is this wrong? This is my concern right now. DP 0 start is equal to 0. For I equals 0, I is less than n, I plus plus. For j equals 0. Check my code forces inbox. What happened there? Wait. I'll respond to that later. I think that's a good idea. You could also just ask me here if you want it to not be a secret. Yeah. What really is going on here? What's inside this message? Okay, so yeah, let me figure out what's happening right here. why would it be negative infinity when it's like not? Start exists, right? Like we're reading the input. This context is that I'm basically doing a bunch of problems, and they're all dynamic programming. And so right now I'm trying to figure out why this program is wrong because it doesn't make sense. But the rest of the video is all about dynamic programming. That's the idea. I'm picking a specific topic and like going ham on it. What the hell? Okay, time to print everything maniacally. Let's have this go up to 20, this doesn't matter. How? How did that make it segfault? What? Maybe it's this. Do we only go here? What does it want? It shouldn't be a problem. What? Wait, if I... No, this is fine. The fact that it's 0 is fine, because I'm doing it weirdly where I count the start here instead of here. I don't think that part's the problem. The problem is that... Wait. Okay, wait. If I make this equal, then the problem is that it's accessing this out of bounds. And somehow that changes the original values of the array? Bruh, segfaults are weird. Like, if I make it so it changes less values, it makes it correct. If I make it do strictly less work, it makes it correct. Even though I'm doing maximum here. That's so weird. Other videos for hard DP? Probably in the future, yeah. See, this one's just a trial run. I just wanted to see how this would go, and seemingly it's going pretty well. Okay, I guess this works. I guess the segfault just made it like access the memory that already existed or something. I don't even know. But anyway, don't segfault. I guess that's the lesson. If you want to see explanation of G, you can rewind the video. Does it let you actually? How far does it let you rewind on a stream? This started about 25 minutes back or somewhat. So you can rewind 25 minutes and I think I do explain the statement, I think. Okay, I'll do H as the last one. Possibly in another stream, I'll continue this mashup. Okay, but this will be the last problem I do. Kind of getting tired right now. So we'll leave it as this. One second. What is going on in this problem? Admittedly, I am losing my focus right now, but I mean, it kind of comes from experience. Like, Yusuko is 4 hours. Yusuko is 4 hours, so I have to be mentally prepared to be able to do that. And like, Code Force contests are 2 hours, so going until 3 hours isn't that bad of a stretch. I've done 5-hour streams before, and those were terrible. But this is relatively fine. You say K? We'll see, we'll see. It is the middle of 2018, false, and Maria Stepanovna, who lives outside, I can't say this, who lives outside of town, wants to rent 3 displays to highlight an important problem. There are N displays placed along a road, and the ith of them can display a text with font size SI only. She wants to rent 3 displays with indices I, which is less than J, which is less than K, such that the font size increases if you move along the road in a particular direction. Interesting. Okay. So the idea is as follows. Let's wait. This isn't so hard to solve. This isn't as hard to solve as to find a good way to explain this. So let's figure this out. If you have a link in a message, I think YouTube like automatically removes it or something. I thought I had that setting to not happen, but apparently it does anyway. So I don't know. Okay, so this is problem H. And the idea with problem H is you have 2 arrays. One array is an array of values, font sizes, okay. And the other array is an array of 30, 20, 10, 40. Basically, you want to pick an increasing subsequence of size 3, such that the sum of costs of the elements in the subsequence is minimum. Right now, I'm doing problem H. So you want to do this. So you want to pick 3 elements so that the cost of the 3 elements is at like minimized, right? So the idea here is that if you're at some element, so again, we asked the question, if you're at some element and you want to put this element in a sequence, say, like what matters about it? So there are 2 possibilities. This element is the beginning of a sequence, in which case this is element 1, or there's some other sequence that this extends. So therefore we'd have to extend some sequence before it. Also, the basic idea here is that brute force isn't going to work because n cubed doesn't pass, but that's irrelevant because you could either begin the sequence here or extend a sequence from a previous one. So to extend a sequence, this previous one has to have been the last element that was placed in the sequence. So why don't we do it like this? Let dp of I, where I is the position, and let dp of I be the number of things where this is the last element, or I is the last element in the sequence. Or not necessarily the last element, but the last element that's been placed so far. And then we can say that, well, we also care about the fact that the sequence is of length at most 3. So let's do something like so, where we also include the number of elements that have been in the sequence so far. Len, for example. So actually, it wouldn't be that I is the last element. It's that I is at position len in the sequence. Then this would be the minimum cost to make this happen. Right, okay. Now, how this would work is, again, the transition is either I'm going to do pull dp here because I don't know, why not? The transition is either you begin sequence, then this would be dp of I1, because it's the first element, and then it's just the cost of that element. Or let's say ci, or extend, then it's dp of I k is equal to some previous value j in the previous position plus ci. And essentially, this value j must be before I. So it's under condition that j is less than I. But like, that's it. That's it because that's just the recurrence. Either you begin the sequence or you extend one. And if you extend one, then it depends on some previous dp value. So let's do that. What will this be? Same to n. And this would be the cost. Then what would this be? dp of n and 3, or n plus 1. For j equals 1, j is 2. So then simply dpi 0 is defined to be where it's the 0th position, so it's just the cost. K equals 0, k is less than I, k plus plus. So then dpi j equals infinity. Let's just initialize it to that. And then it must extend some other sequence, so it would be dp of jk minus 1, dpi j equals min dpi j, dpi dpk j minus 1 plus ci. And then ants equals min ants dpi 2. because we can have it so, because this is the sequence where the length, the thing ends at I, we have to consider all possible endpoints, so the answer would be the minimum over all dpi in 2. If no such sequence exists, then we'll print -1, which means the answer would still be infinity. And we get 60, which is somehow wrong, because I don't actually check. Right. If AK is less than AJ, strictly less, that's the condition. Now we get 80. How does that happen? Strictly less. Why is it not behaving like strictly less? I equals 0, I is less. Oh, this should be I, not J. Whoops. Should be 33. Looks right, I think. We use I here, I, J, K, I, J. Yeah, I believe in it. I believe it's probably wrong. I don't know. Doubt is a thing. Okay. You said you want me to try problem K? I can do problem K, and that can be the last problem, and I'll end the stream here. Or something. Because this is probably enough for everything. But alright, so... Okay, this is flavor text, I'm going to ignore it because I'm not ready to do anything. Sequence of L integers, where it's increasing, is... Yeah, okay. So K is going to be the last problem I do, and then I'll end the stream here. After that, we'll leave the harder problems for later. Although I suppose E was also a relatively hard one. Although most of these are going to be the worst. So the next stream will kind of be more of like an advanced section, I suppose. That will work that way. And then maybe we'll do some custom problems or something, which are probably going to be even harder. So that's fun. Alright, sequence of L integers is called good if each number divides by the next number by the next number of the sequence. Wait. Okay. Each number, yeah. Divides by is like confusing, but each number divides the next number. Given n and k, find the number of good sequences of length k. Okay, sure. So once again, we figure out the way to derive the state. What are we going to build the dp on? First, we have to include the position, as always. And then say we're putting some number down. For example, we have like 2, 2, 6. Yeah, this is the last problem. It's going to be over after this. And we want to put some number x. This is a 6, by the way, not some other thing. Then all we care about is the fact that x divides 6, or 6 divides x, which means x is divisible by 6. And what this means is essentially the only thing we care about once again is the previous element. What was the last problem we did? Wait, was that the time one? No, it was that. Okay. So basically the only thing we care about is the last element. So let's make this the last element. And then this will go out to dp of I plus 1, and then x, where last, or x is divisible by last, or last divides x. Yeah. So like, nice. What would happen here? Did it just remove my message? Okay, interesting. I guess YouTube is doing stuff to my own chat. But basically it just says that we want to push this value out to all multiples. So, like, what's the deal? Isn't this like a high complexity? It would be, but the trick here is that it turns out to not be, because how many multiples do we have of I? Of 1, we have n. Of 2, we have a number on the order of n minus 2. Of 3, we have a number on the order of n minus 3. And in general, we have a number on the order of n over I. And the total complexity for a single value of that is this. The sum from I equals 1 to n of n over I. This is the harmonic series. It's like provably O of n log n. I'm not going to describe it here, but actually I did write a blog on this. Let's just find that right now, because why not? And then I'll link that, and we'll just leave it as is. But essentially this sum is going to be O of n log n. So the total thing is going to be O of, what would it be? K, good sequences of length K. So K times n, which is the maximum value, n log n. And that's basically it. So let's just do that and finish this off. There's some formula or something, but who knows? I don't. So this goes up to K, and this goes up to n. So dp m plus 1, k plus 1. And we say it like, we have one way to make 0 and 0. Memset will just fill it with a value, but be careful with memset. You should probably only use it for 0 and -1, so I heard, because of the way it works. Like, it's not what you expect. And the way this works is you just kind of like push this out. How would this be a base case, actually? Maybe it'll be something like this. We instead say this starts at 1. And then we'll put a virtual 1 at the beginning of a sequence, meaning that like all of these values are going to be at most n, but they also divide 1, so that kind of works. J equals 0, j is less than... Wait, this should be k, and this should actually be swapped. b equals j, b is less than or equal to n, b plus equals j. This is the multiple of j. We do mod. It's the first time we're actually doing mod. Nice. dpi j equals, no, I plus 1. The next value at v is that. And we have to do the mod and stuff. Yeah, but memset is weird. Like, as you said, it does by character, which means if you try and set it to like 1, it's not going to be 1. Like, it's going to set every 8 bits to that, which means in a 32-bit integer, you're going to get something like that, which is clearly not 1. But with with 0, it's just setting it all to zeros, and with -1, it's represented like this, which is universally -1. So it only works as you expect for those, as far as I know. But I'm not an expert on memset. You can probably read documentation if you want. Anyway, and the answer is the sum of all possible like previous values, because it doesn't matter what it is. Ants equals ants plus dpki mod mod. Alright. Run the what? I have to read it. Nice. 5. 39. 2. We do mod. Everything's good. Yeah, this stream will be archived on my YouTube after. I think YouTube may take a while to process it, but it'll be up eventually. Okay, and that's basically the idea. We do first the position and then the element, and then we push it out to all multiples, and it just works because of the way the harmonic series works. All right, well, that's all I have. Okay, I think in terms of the stream, that's it. Colin Galen signing out. Or signing off. Yeah. Or Kalen Galen, whatever you want to call me. Alright, this was fun. I guess we can continue this later. Maybe like more of the mashup or more of the anything or the implications of this message, which you will all find out later. Okay. Yeah, alright, goodbye.